All right, continuing with our idea of functions. And again, guys, be gentle with yourself. For most of you, this is a new concept, and it's brand new, but just with some practice, you'll get these basic concepts. And it's not that difficult. You can do it. I know you can. Okay? So, something that we work with coordinates, with points and graphs and things like that, is called domain and range. And domain, go away, is all values of x, meaning that in any relation or function that we have, which is points, set of points, that there's always in every point an x coordinate and a y coordinate. And so that x coordinate is part of your domain. Every single x coordinate, every single point has an x coordinate. Every single one of those x's is a value, and that value is part of your domain. Range, then, is all values of y, meaning that in every point there's an x coordinate and a y coordinate. The y coordinate, the value of that, whatever that number is part of the range. So when we have just a set of points, it's really easy. Domain equals, and because this is a set, we have to, this is the only time, guys, that I ever want you to use set brackets. Because this is just a set of points, our set of domain has to be written like this, the set of, and then all we do is take the x coordinates and do not repeat them. So we have a 3, a 4, and a 6. So domain in this case is a set of 3, 4, and 6. Range, then, again, because this is a set of points, we would have to write it as a set. And we're just going to take the y values and 8. So the range is the set -1, 2, 5, and 8. That's all it is. So if you have a set of points, just for domain, just pick up your x's. For range, pick up your y's. Okay? Now, we are going to look at graphs now. Okay? So most of what we do with functions and domain and range has to do with graphs. Okay? So there is a really cool test that we can do if we have a graph. Okay? Let me go back here and write this in. Called the vertical line test. We want to use this to determine if a graph is a function. Will you just stop that or not? Okay? So, vertical line is one that's straight up and down. And here's how we do it. Okay? So, if I have a graph and I want to determine if it's a function or not, I draw a vertical line through the graph. The graph is this part here, guys, the picture of what my equation was, which we don't even really care about that right now, okay? The axes are not part of your graph, okay? So be careful, don't be thinking about that. So it doesn't matter where I draw my vertical line, but here's what does matter. If that vertical line touches my graph only one time, then this is a function. If it touches it more than one time, it is not a function. So this vertical line touched this graph only one time. So this graph is a function. Now, please don't write these things, domain and range, on the graph paper. Write it on regular paper, but I'm going to put it here so that we can see the relation. So what I want to do now is figure out what domain and range of the graph is. Okay? So what I do, and first of all, when you're writing domain and range of a graph, it must be in interval notation. So if you need to go back and review interval notation, then do that. Okay? So what I do is I'm going to start here at the origin, and I'm going to go left and figure out where I have x's on this graph. Okay? So if I start here, I come up here, and this is on my graph. Do I have an x coordinate? Well, I do. It's a 0. I don't really care. If I come over here, do I have a point on the graph still here? Yep. And it would have an x coordinate. If I came over to here, would there be a point right here on this graph? Yes, there is. Would it have an x coordinate? Of course it would. If I come over here, now remember the arrow means that this is going in this direction forever. So is there a point on the graph? Yes, there is. And I would keep going out this way as far as I could go until there was no longer a graph, the graph where there would be an x coordinate. In this case, it means it's negative infinity. This is going all the way to negative infinity. And remember, in interval notation, I can never do a bracket, okay? And so then I'm going to put a comma, and we're going to go the other way. So we're going to start here again, and we're going to go this way now, to the right. So do I have, if I were to come right here, let's say, do I have a point on my graph? Yes, I do. And it would have an x coordinate. If I come here, do I have a point on my graph? Yes, I do. And does it have a x coordinate? Yes, it does. Well, it's basically exactly the same thing because this guy keeps going in this direction forever. And so this is going to be positive infinity. So my domain of this graph is negative infinity to positive infinity. Now let's do range. Okay, so think of turning this graph 90 degrees, and so that this going down is actually going to the left and going up is going to the right. Same thing though, so that when it's the x, the domain, going to the left is our as far left as we can go, going to the right is as far right as we can go. So for y, our range, going down is as far left as we can go, let's say, and going up is as far right as we can go. So going down, if I start here, again at the origin, and look at this graph, do I have an y coordinate? I've got, just don't know why this keeps coming in. I'm sorry about that, guys. If I were computer literate, I might be able to keep that from happening. So we would have actually two places where we've got y points and y points, and it's got y coordinates. So as I go down, again, because these keep going in both directions forever, I'm going to be able to go until it's negative infinity, because remember, this is kind of like going left. So now when I go up, okay, if I go here, do I have points on my graph? Yes, I do. Okay, do I have a point here and here? Yes, I do. I get up to the 4, and I no longer have a point on my graph. I mean, beyond that. So 4 is as far up as I can go. But is 4 also included? It is. So I have to do a bracket. And that's my domain and range. Now let's look at this one. Okay? So again, first of all, let's decide if this is a function or not. Okay? So I'm going to draw a vertical line. How many times did this vertical line touch my graph? Well, it touched it twice. And so this is not a function, okay? But let's do domain and range, because we can still do domain and range whether it's a function or a relation. So as far left as I can go is to the 4, because everywhere along here or along here as I'm going left, there are points, okay? But as far left as I can go is -4. Once I get past -4, there are no more points. Same with going right. As long as I'm going to the right, there are points on this graph all along here. But once I get past 4, there are no more points on my graph. So my domain is everything between -4 and +4. Now let's do it the other way. Going down for range, for our y. Again, as long as I'm to the -6, I've got points on my graph that have y's on them. But as soon as I get past the -6, there's no longer a graph. So I can go as far as -6, and -6 is included. When I'm going up, same thing. I can get up to 6, but I can't get past 6, and that's the domain and range. Okay? Anytime you have a straight line, first of all, it's a function. And second of all, domain and range of any straight line is automatically -infinity to +infinity. Just keep that in mind. How about this one? Well, it is a function. Domain, so left to right, is going to be -infinity to +infinity. Range, I can go down as far as -3, but I can't go past that. But going up, these are going in that direction forever, so I can go to +infinity. How about this guy? We aren't going to do domain and range. We're just going to look at whether it's a function or not. Cool looking graph, right? Oh, look at that. 1, 2, 3, 4. Definitely not a function. How about this guy? Also cool. Anywhere I draw my vertical line, touched it only once, so it is a function. So that's vertical line test and domain and range.